Hey everyone, this is Matt Perez, and today we're going to start a new series talking about molded parts. We're going to take a look at creating a mold inside SolidWorks, then we're going to move on to Mastercam and actually make some NC code for this. Now the part that we've chosen is one of these arms off of this robot here. And the reason we've done that is it looks like a simple part, but it's actually got a lot of complicated procedures that we need to follow to make this thing work. A lot of things that SolidWorks does well in the mold tools, there's also the same amount of things that it can't do. So we're going to take a look at this part and we're going to show you how to manually do a lot of these features when you run into problems, because that's where everybody has questions. I mean, you can follow a tutorial and you can go over just creating these, step by step for simple parts, which is always what you see in the tutorial. But then when you go back and you start working on your own parts, you find out that's a little bit different, it's complicated, things aren't working right. You figure out these kind of workarounds and these little tips and tricks. But first, let's go ahead and take a look at a very simple part and see how everything should work. So first, we're going to insert our mold tools. We're going to do a parting line analysis based on our part. We got 3 degrees of draft, and we'll just go ahead and OK that. And you'll notice that everything's either red or green, and our parting line is where we expect it to be. So we can hit OK. In this case, we don't have any shutoff surfaces because there are no openings in our part. So we can go straight to creating a parting surface. Now our parting line is nice and simple. The parting surface is going to be very easy to create. So I'm just going to do an extension that's 2 inches outside of that. Alright, and the next thing we do is a tooling split. We're going to select our parting surface, and then we're going to just draw a rectangle. And this is going to signify the shape of our mold. And I could apply dimensions to that, but since this is a simple case, we don't need to worry too much about it. And you'll notice here what happens is SolidWorks grabs the outside surface of our part, it's calling it our parting line, the pink selection here, as our core, and then the cavity is actually selected in light blue here, and that's all the inside pieces here. And then our parting surface is in purple. So we hit OK, and SolidWorks has gone ahead and created both halves of our mold. So let's go ahead and hide the original part, and in this case I'm just going to hide the bottom and take a look at what we have. We also have our surfaces here that we need to hide. We need to make sure that they're not obscuring what we're looking at. And we can also hide our parting line. So you can see that we have a core. If we show the other side, we have a cavity, and we have everything that we need to create this mold. So now that we've taken a look at the simple example, let's go ahead and hop back and take a look at the complicated example and see where we're going to have to make those changes. So let's go ahead and start and take a look at this arm right here. So as I said, as we look at it, it looks fairly simple. Everything is drafted, but where we're going to start to notice some problems, and you guys might come across this from time to time, is that we're going to have some undercuts in here. So we're going to have to make some separate core pulls to actually make this work as a molded part. Now, in reality, what you would probably do is modify the part itself. If you were going to mold this, you might consider doing a depression on the top hand side to make sure you don't have that undercut, or maybe even just cutting this whole section out altogether. For this part in particular, there's actually a gear that goes here, and it's kind of important to us that we have this full perimeter around it. So we're going to go on the assumption that we can't modify the part. We need to just make a mold that will allow this to work. So that's the complicated part, and that's where it gets kind of tricky for us. So let's first start by taking a look at a draft analysis. So we're going to pull from this face, and we're going off the assumption that everything has at least 3 degrees of draft. That might be because we need a texture on the outside of this thing. You could obviously get away with less draft, but we're going to set 3 degrees for our part, and we're going to use that as our rule here. So you see everywhere is green or red, so that means it does have the appropriate draft. But as I mentioned, these areas here, they're actually undercuts. So they're going to start to produce some problems when we go to try to pull this thing from the mold. It's essentially going to be locked in place. So we know that it's got appropriate draft, but we know we have these undercuts. So let's just take a look at the undercut analysis and see what it's telling us. Make sure we don't have any other areas that we're worried about. So as you can see, everything that's dark blue and light blue has a positive or negative draft. There's no undercuts in those areas, so they're calling it direction 1 undercut, direction 2 undercut. We don't have any straddle undercuts, so these are going to be areas that are both positive and negative. But we do have these occluded undercuts, and what it means by that is occluded means you can't see it from the pull direction. So we have this area that we're going to have to approach at some point, but we're really going to take care of that after the mold's been created. That's going to be when you're going to create these, what they're calling a core or a side pole is what you typically call it. So we're going to have to create that. And this particular instance is special because it's not a true side pole. And that's kind of the reason we're using this part, is because when you do a typical core tool in SolidWorks using the mold tools, it's going to want to extract that all the way out of the side of the mold. And if it does, then it's great. It works fine, and there's draft on it, and it can be ejected from the mold. In this case, we actually have this occlusion on both sides. So we need to create some features that allow us to have a wedge in the middle and then pull these two parts out. So it does get a little bit more complicated, but now at least we know what we're working with. So the first thing I want to do, because when we were looking at that undercut, we noticed that it came all the way under this section, because you can't see that behind this face here. You can see this area is kind of occluded, as they call it, an occluded undercut. So the first thing I want to do is split these faces to kind of signify that. And that's going to help us when we're going to do a parting line. Now the parting line analysis isn't going to work great on this part, because it's actually going to come up and go around this area in here, and it's going to get kind of complicated. So again, what looks like a fairly simple part is going to give us all the little issues that we need to figure out along the way. That's what makes this part so great, because it's simple, but at the same time it's somebody's headache that they have to figure out how to make this work. So the first thing I'm going to do, and there's several different ways that you can do this, but the first thing I'm going to do is create a new plane. And my plane is going to be 0 offset from here. And the reason I'm doing a plane is because I want to use a split line. If I was just simply going to split the part into multiple sections, then I could just use the split tool, or we could use other tools. We could draw a sketch and so on. But I'm just going to create a plane, and then for my curves menu, I'm going to do a split line. And that's going to be an intersection split, and I'm simply going to select these outside faces of the cylindrical area here. So you can see that that plane went ahead and it split our faces here. So now I can hide that plane, and I can do the same thing on the other side. So reference plane, 0 offset. And then again, we're going to go to our curves menu, and we're going to use a split line. And again, it's an intersection. And this time it's only going over here because it's actually splitting all the way through, and that's okay. That's nothing to worry about. We're not creating any extra geometry that's going to cause us some errors. Alright, so we've taken a look at splitting that. So now we're in good shape for actually starting to create some mold features. So we're going to go over to Mold Tools. We're going to first insert the mold folders. If you're dealing with 2014, then you need to manually insert this. And what that does is when you expand your surfaces folder, which right now is hidden in my tree because we don't have any surfaces, but when you expand that surfaces folder, this insert mold folders is going to give you a core, a cavity, and a parting surface folder. And it just helps simplify the organization of everything. So the first thing we want to do now that we've inserted that folder is go to parting lines. And parting lines, we're going to select a planar face or a plane, something that gives us the draft or the pole location, the pole area here. So we've selected that face, and I'm going to go ahead and just select split faces, even though I know in this case it's not going to split anything for us. But this is a handy thing to turn on if you might have some sort of straddle geometry where it's going to go from positive and negative. It can go ahead and use a split feature to create that. So we're going to, instead of just hitting OK, we're going to say draft analysis. We want to take a look at this. And this is where I mentioned we're going to have a problem, because it's trying to do our parting line all the way up in here, and it thinks that's okay, but obviously that's not good for what we're trying to do. That's not where we want that parting line to be. So I'm simply going to right click over here, and I'm going to clear all that. And even though it's going to take a little time, I'm going to do this manually. And this is exactly why we created those planes and why we split this geometry up, because we want to make sure that we're selecting the exact geometry for the parting line that we want to use. So if we didn't split these originally using the planes that we created, then we wouldn't have this selection process here. And that would just make this a little bit more complicated. As I mentioned, that split faces option isn't going to produce the type of split that we wanted in this case. So now that we've selected all the areas that we need for our parting line, I'm going to go ahead and hit OK. So now we've got a parting line where we want it, and everything's looking good here. So I'm going to go ahead and I'm just going to save this. I want to make sure that I don't create any issues in SolidWorks where it might crash. So I want to just save the work that we've done. And just to reiterate, we created the planes, we split these faces, so we have a good selection for our parting line. So now we're in good shape to make some shutoff surfaces. And these shutoff surfaces are really only going to be in these bolt locations. And everything's drafted to pull from the outside as we're looking at it. So our shutoff surfaces are going to be on these bottom edges here. So let's go ahead and use shutoff surfaces. You can see it selected both edges. Now we cannot use the knit option here because we have two divided surfaces or separated surfaces here. We have patch type options, but since we're dealing with basically a planar patch, I'm not going to worry about it. We can do show preview and we can take a look at what's actually going to be created. Callouts, that's just going to show this loop if we were going to, instead of doing contact, if we were going to do some sort of patch that had tangency, we could do that and we could show that. We can turn that off. We don't really need to see it. And the filter loops, I'm just going to leave that on. We're going to go ahead and hit OK. All right, so now we have our shutoff surfaces. And again, I'm going to go ahead and save this. Now, this is going to be where we're going to start to see a few problems as well with our parting surfaces. It's going to create some geometry because of the way our parting line is created, because it's not all in the same plane, it's not simple geometry. We have this little step here. This is where things are going to start to get complicated. But we're already at 10 minutes in this video, and I know it's a lot to watch, so we're going to go ahead and we're going to stop it there after creating our parting line and our shutoff surfaces, and we're going to pick up creating the actual parting surface off of our parting line in the next video. So hopefully you join us next time. As always, if you guys have any questions, please email SolidWorks support at mlc-cad.com.